So this is the second half of chapter 1. I'll try to make it a little bit quicker this time. There's not as many learning indicators, but you need to make sure that you understand the math for this chapter. The first thing we mentioned when we were talking about this chapter, and this is in the learning indicators, it's applying the metric system to measurements. So you need to make sure that you know that we use a meter for length, we use a kilogram for mass, seconds is time, Kelvin is a temperature, and a mole is an amount of a substance. And these all work together, and you'll be given a chart kind of like this. All of these work together, and I'm going to erase this all in here so you can kind of see it's seen a little bit better. The chart you'll be given won't have M's in it. It'll be missing that section, and it'll just have an F, and then on this side it'll be called a base unit. So in the case of a meter, M, meter, is the base unit. You need to know how to use this chart, and you need to know that this won't be given, that there's a 1 that goes in front of the thing that has a prefix, and that this number over here is the base unit number. And the way you put it in is you put it in your calculator as 1 times 10 to the. So all of these are like 1 times 10 to this. Which of course I know makes it look like it's just the number, right? But if you use the E key takes care of this section right here. So that's your E key right then. So that if you put the 1 and then you use the E key and then negative 15, you'll get the right number. Okay, so the idea of dimensional analysis and using dimensional analysis or unit conversion or whatever you want to call it is that you start with a number right here and you have a unit right here. You write that number and the unit down, and the key bit to all of this is that you immediately on the bottom section put that same unit, and then if you're not sure what to turn it into, especially if it's metrics, look back at the chart. So we look back at the chart, we're looking for something that's like a milli, and so right here, that's where the milli is going to fall, and it's equal to this many of the main base unit. So in this case, it was a liter, so this is a milliliter, and this is going to be related to a liter. So you know you can write down a liter on the top, and then you just fill in the numbers that are on the chart for the different amounts. And here's another example again of how to use that EE key if you don't know how to use it. If you choose not to use the EE key, you need to make sure that you're using parentheses, especially, it doesn't matter as much on top, but if you're using you're not using the E key with something on bottom, you've got to have parentheses. And we had some different examples. Notice that you can make these longer. And so this was a milliliter, is that same number, and a milliliter. And we're going to convert it. You might have wanted to convert it straight into a megaliter. And if you've had a lot of chemistry and you're really comfortable with doing that, you probably could get away with it. But most people are going to want to find something that the milliliter is equal to. So again, the milliliter, this is the only spot that it's on that chart. And here's what it's equal to. So I can't just say, oh, I want this to be equal to this and somehow set up a relationship with them. I have to say the left guy is equal to the guy on the right. So I have to take it into a liter right here. And then once I'm in a liter, then I can go back to the chart and say, can I get to my megaliter from there? You're like, oh, that's where the mega is. So I can get from, again, we could call this a liter instead of a meter. And say, oh, I can get from a liter to a megaliter. So that's how you would know, okay, yeah, I can do the next part of this conversion right here, liter into a megaliter. And then you always put the ones with the prefixes. Notice that has a prefix. That's the one with the prefix. And then you use the numbers of the chart for the base units. And you can also do this with double units. So I've got a really good example right here with double units. So we started with the 2 grams. And it says per 300 milliliters, so per means divided by. It can also mean equals, but That's the only number in here, so it's per divided by. So we've got 2 grams on top, and then we've got our milliliters on bottom. You can choose to deal with the milliliters first or the grams. In this case, dealt with the milliliters first. So we have the milliliters here, so you write the milliliter unit on top. And you can always take any milliliter to the base unit, liters. And then, this is just like in that earlier problem, you can take your liters again to the megaliters. Once you get done with that, you still have a gram per milliliter. So once you get done with that, then what you want to do is you want to take your gram and you want to turn it into your kilogram so that you have kilogram per megaliter. And there's some methods in here to show you how to put it in your calculator. So that's the idea of unit conversion. You can make them really long. If you prefer using this method where you're doing the lines, that's fine. If you prefer using times and these kinds of lines, that's fine. Or if you want to use a dot, that's all fine. These are all fine methods, whatever works for you. And this chart would also be given to you. And this chart works similarly to the last one. It tells you what things are equal to each other. So you just want to make sure that you know that if you are given an inch and you want to turn it into a centimeter, you start with an inch and an inch, because you've got to immediately write the inch down and you convert it into the centimeter. When you convert it into the centimeter, you're done in that case and you're left with 36 centimeters. And it works the same way. Again, your mile turning into a mile and your meter turning into a meter. All these are really well spelled out and really worked out. And there's a ton of these in your playlist of unit conversion. So if you need any help with any of this, there was also a lab on all of this. So if you need help with any of it, there is definitely help to be had. But you need to ask soon. Okay, and then the next question is, how do you deal with cubic units? Well, right here, this is what's tricky. Right here, if we have a cubic unit, I can't say that 1 centimeter is going to cancel out all 3 of those centimeters that are in that cubic unit. All he does is he just cancels out one of them. So I'm left with some kind of weird units going on at the end. So instead, whenever you have a cube unit, what you have to do is you have to do a centimeter into a meter, centimeter into a meter, and a centimeter into a meter. Okay, so the other last bit of something you need to be able to understand is density and solving problems using density. So there are a lot of different types of problems in here. When we looked at volume, this is an important piece of density. Oops. Right here. We did this in class. If you put water in a container and you have the measurement for it, and then you put like a drop of some kind of a item into the container, it's going to raise up the water. When you do that and you do the difference between the two, you're going to end up with how much the object's volume occupies. So this will tell you the object's volume. The other way to do it is to actually measure all of the sides of the cube, which would this be showing you like measuring all the sides of the cube and multiplying them times each other. As far as do you need to know how to deal with a beam or a sphere, don't worry about those two. You want to make sure that you do know how to do a cube or a rectangle. Now this is not given on your special sheet. You've got to memorize this one. Density is mass over volume, and most of the time the units that match with this is a gram on top and a milliliter on bottom. It could be a gram per liter though, sometimes that happens too. So your density should always have 2 units. So if you take that same object from before and you put it on a scale, so you can see the picture of the little scale here, and this is the measurement of the scale, that's only the mass part of it. That's the mass. For density, you need to be using both of them. So here's your mass and here's your volume. So again, this would either be something that you calculated by measuring all the sides of the cube, or something that you got the volume from dunking it in a graduate cylinder and seeing how much the water changed by. You need to be able to use the density equation in different ways. So this is still the density equation right here. That's still the density equation. If you want that density equation to solve for something different, remember that what you do is you're multiplying both sides by this v. So multiply both sides by v, and it cancels him out, and that's how you get to this next step. D times v is m. Now, if you didn't want m, if you wanted to solve for v, then you would divide both sides by d, and you're left with v equals m over d. So this is one other version of the equation. And then again, if you go over, here's the original version. And if you want to get to the next one, you multiply both sides by v. You get d times v is your mass right here. So both of these equations, once you get them to what you want them to be, you just have to identify in the problem what the problem gives you. So like right here, whenever you see a g, that's the mass. And like in this problem, they don't give you a mass, they want you to solve for it. And the thing that has 2 units, that's going to be your density. And of course it says this right here. That's your density. So that's another hint of what to solve for. If you have the m and the d, then you're going to need to solve for the v. And then over here on this side, again, we have the d, and then we have 2 numbers for the volume. So this is describing, again, what's going on. The water in the bucket begins at one amount, and then after you put the thing in, it becomes 180. So the volume is 180 minus 80. That's the volume of whatever you put in the object. That is your volume. So we know the density is this number here. Here's our density. So we know it's that number. And then our volume, we had to do a little bit of extra math. Make sure that you can do that extra math to get to the volume of it. As far as whether or not you have to be able to do these conversions, in the lab, you're definitely going to have to know how to do it. And in the future, you're going to have to know how to do it. So you should memorize these 2 equations right here. And I know they're not listed on the learning indicators. The most important one is going to be the one for the Kelvin. All right, so that's the end of chapter 1.